Hello, everyone. This is the homework take-up for the distance between lines and points in a line. Okay, so let's take up number 14 and 15 from the textbook. Okay, I also sent out that message that apparently the handout for additional practice didn't get uploaded to the website correctly, so that's fixed now. So for tomorrow, you can also send me questions from that handout, and I'll do it in tomorrow's homework take-up video. Okay. So here's number 14. Gives us the equation of the pass of two jets. Okay, the first jet is just S841. So the fact there's no point there would suggest it comes from the origin, right? It would be the point 000, which I wouldn't really need to write down because it wouldn't affect anything there. Okay, so just for reference, I'm just going to toss that in there. But that's what's happening there. That's why there's no point listed. It's 000 plus S841. Okay, and there's a second jet. So to summarize what the question was asking, part A asks, do these paths meet? Okay, if they do, find out where. If they don't, what's the distance between the paths? Okay, and finally, if they do meet, does it mean there's a collision? Okay, so starting with the paths, will the paths meet? So that's a question of whether these two lines intersect or not. Okay, so we're going to go back. I think there's a couple lessons there and go through our process for intersection. Okay, so my first line, and I'm just going to speed this up a bit by just listing them out. Okay, so right, I have my x, y, z. Okay, so for my first line, again, I had all those zeros, so my parameters are just 8s, 4s, and s. Okay, for my second line, my parameters are 60 plus 2t, negative 20 plus 6t, and 22 minus t. So I'm going to pick a pair of these equations and try to solve it for t. Now, the last equation is very nicely set up to use in substitution. So I'm going to put this, I think, into equation 1. Okay. And see what happens when I try to solve it. So I'm going to pop this in here and see what I get. So 8 times 22 minus t is equal to 60 plus 2t. Okay, so 8 times 22, okay, 176 minus 8t is equal to 60 plus 2t. I'm really hoping this is going to work out to nice numbers, but I'm not sure that it will. Okay, t comes over, so I have 10t. 60 comes over, it's 116. So that's a reasonable decimal. 11.6 is equal to t. So s is 22 minus that. So now s is 22 minus 11.6. So s would be equal to 10.4. Okay. So I got s is 10.4 and t is 11.6. So now I have to plug that into this equation in the middle and see if that actually works. So I have 4s. My remaining equation is 4s equals negative 20 plus 6t. Maybe. So 4 times 10.4 negative 20 plus 6 times 11.6. Okay, so 4 times 41.6 equals 49.6. Okay, so those don't equal, so therefore these two lines do not intersect. Okay, so that answers part A, right? Will the path meet? So the answer to that is no. Okay, so if not, find the least distance between them. So now I have to find the distance between these two lines. Okay, so let's review the process here. First, let's check if they're parallel. Okay, so I look at my direction vectors. They're definitely not scalar multiples because you have to come, it's got to be smaller to go from 8 to 2, but bigger to go from 4 to 6. So that doesn't work. Okay, these are skew lines. Okay, so I need to find the vector running between them, and I need to find a common normal between these two things. Okay, so I'm just gonna maybe copy my equations down here so I can see what I'm doing. Okay, so first I have to find the common normal between the two lines. So my normal is equal to 8, 4, 1 crossed with 2, 6 minus 1. All right. So -4 take away 6 is -10. 2 plus 8 is 10. And 48 take away 8 is 40. Ooh, that's handy. Okay, so this is similar to -1, 1, and 4. Okay, that's very convenient. Okay, next thing I need is my point from A to X. So if I call this A and I call this X, that again is very nice. It's just going to be basically point X, right? -0, 0, 0. So my vector A to X equals 60, -20, 22. Okay, now that one I can't shrink. Okay, I need to know how big that one is before I project it. Okay, so final step, the magnitude of the projection of AX onto the common normal is equal to magnitude of AX dot N over magnitude of N. So I'm going to have -60 minus 20 plus 88 all over the square root of 18. Let's see, I'm going to have -1 squared plus 1 squared plus 4 squared. Okay, yeah. So 8 over square root of 18. 8 divided by square root of 18. And that is 1.88. Oh, hold on. 89. If we're around that at that spot. Okay, so that's the distance. So going back to my presentation here, it was 1.89 units. Okay, for part C, if the paths did meet, okay, does that mean there's a collision? Okay, short answer to that is no. Okay, and just to visualize why, okay, if this is the path of my first plane, okay, and this is the path of my second plane, and say they meet right there. Okay, well, sure, okay, they meet there, but it depends on the speeds the planes are flying. Okay, this plane may be flying along here. Okay, and this plane may have been following this path and already be past that point. So if we really want to answer this question in detail, we need to know something about the speed of the planes and then figure out how far along the line this has actually traveled. Okay, which is a more complicated thing to do, but it can be done. Okay, but yeah, it has to do with the speeds and the positions the planes are on that line. So short answer is no, it doesn't necessarily need a collision, but it is a possibility that's there. That could make a really cool assignment question. Okay. On number 15. Number 15 has these two lines. Okay, part A asks us they are parallel. Okay, and again, quick check of the direction vectors. 1 times 2 is 2, but 2 times 2 is 4. That doesn't work. So no. Okay, these are not parallel because the direction vectors are not parallel. Okay, do they intersect? Okay, we just talked about how that would work. Okay, now part 3 says what's the least distance? Okay, so that kind of suggests we're not going to have an intersection here, although if they meet, the distance would be 0 and it would be done. So let's set it up the way we did before. Okay, I'm going to do the abridged version here. So the parameters from the first equation, okay, my first one is 7 plus s. My second one is 7 plus 2s. And the third parameter is negative 3 minus 3s. Okay, from my other equation, okay, my x parameter is 10 plus 2t. My y parameter is 7 plus 2t. And my final parameter is 0, so I don't need to write that down, minus t. Okay, and we've got another one that sets up nicely for substitution. Okay, I can peel off all those negatives, and this is 3 plus 3s is equal to t. Okay, and then substitute back into the equation of my choice. So maybe I'll run it into, let's say we'll do this one right here. Okay. So I have 7 plus 2s is equal to 7. Hey, wait a minute. Before I do that, let's make my life a little easier here. Okay. 7 plus 2s equals 7 plus 2t. Those 7s will cancel. So 2s is equal to 2t. Oh, that's even nicer. This just says s equals t. Okay, now let's substitute that in. And that is so much nicer than it was before. So s equals 3 plus 3s. So that means negative 2s equals 3, and s equals negative 3 over 2. And s and t are supposed to be the same. So that means that t must also be negative 3 over 2, because we saw that right here. They're supposed to be the same. Okay, final thing is to check if that works in our remaining equation. So in that top equation, does that work? Let's see, we've got Okay, 7 plus s equals 10 plus 2t. 7 plus s equals 10 plus 2t. I've got a feeling this might not work, but we'll see. 7 minus 3 over 2 equals 10 plus 2 times minus 3 over 2. Nope, definitely doesn't work. Because this side, I'm going to get a whole number as my answer. That's 7, and this is going to be less than 7. This is negative, this is 5.5. Okay, so no. Okay, they do not intersect. Okay, final part. What's the distance if they don't intersect? Okay, so it's the same process basically as the last question. We're going to have to find the common normal and then find the vector running between them, okay, and project that. So again, I'm going to copy this, start fresh here. Pardon me. So we start with our common normal. I'm going to have 1, 2, negative 3 crossed. There's 2, 2, negative 1. So 1, 2, negative 3, 1, 2. Okay, so negative 2 plus 6, 4. Negative 6 plus 1, negative 5. 2, take away 4, negative 2. Second thing I need is my vector from A to X. So 10 minus 7 is 3. 7 minus 7 is 0. 0, 3, 0, 3. Okay. I need the magnitude of my projection onto the normal of AX. Okay, which is the magnitude of the dot product over magnitude of n. Okay, so a to x dot n. Okay, 3 times 4 is 12, plus 0 plus negative 6. 6. Okay, magnitude of n is 16 plus 25 plus 4. So 45. 6 over the square root of 45. Which is a little less than 1. 0.89 units. Okay, and that's finished. Okay, so thanks for watching. Okay, and again, if you end up having questions about the other homework page, okay, that website handout that got delayed there, yeah, I'll take them up in the next video. Okay, thanks for watching.